So the vertex coordinate is 3, -4. So I already know I'm going to use this equation. That's the vertex form, and you have that on your formula sheet. It's the same paper from yesterday. It's called a recap. It'll say like right on the top. Some kind of booklet separate. You find it? Okay, so when I do this, I need to understand what the slope is, and we can use any other point to get the slope. So it doesn't matter. Does anybody want to pick a point? It doesn't matter which point we use. Should I go with this one right here? Doesn't matter. So that is 5, 4. Okay, we're going to start to plug in. So which letters associate with a vertex? Which letters are going to be the vertex? That should be H and K. So these are going to go into the H and K spots. And any coordinate is going to go into the X and Y spots. Okay, here we go. Y, I'm going to put a 4 there. A is what I'm trying to get, the slope. X is going to be a 5. Okay, subtract a 3 squared plus K, which is a subtract 4. Okay, we're going to do algebra here, so I'm going to have to add 4. So I got rid of that by adding 4. And then 5 subtract 3 is 2. 2 squared. That's 4. So therefore, my A value is 2. Okay, determine the equation. So the equation that I write needs to have the slope and the vertex, and you always have to leave your X and Y's open. So the 3 and the 4 part, I'm going to leave in there. The 2 I can now put X and Y you always have to leave open, because I would go into my calculator like that. Okay, the X-intercepts are given. So this time I'm going to use the other equation on my formula sheet. So this is the equation I'm looking at that is on your formula sheet. Okay, do you remember what factors look like? So if the X-intercept is 1, my factor would have been an X minus 1. Does that make sense? Because we do factors to x-intercepts, so now I'm just going x-intercepts back to factors. If -5 is an intercept, x plus 5 would have been a factor. Okay, when it gives me the y-intercept, what is the actual full coordinate? If it tells me a y-intercept, the coordinate is what? 0, -15? Because a y-intercept is when the x value is 0. Okay, so this is a point, which means I can replace the x and the y, and then I'm going to figure out a. Same kind of idea, just the different format. Okay, so I'm going to replace y with -15. A 0 minus 1, 0 plus 5. Okay, so the R and the S, we're doing the factor numbers, the intercepts, and then the X and the Y is me putting in a point. So what does this all come out to be? So this is a -1 multiplied by a 5. So that's -5, which means A is 3. Okay, so I have to write a final equation though. Y equals 3, x minus 1, x plus 5. So the equation with the x and y's open still. Always that's the goal at the end. Everything except x and y's stay open. Okay, C is kind of like question 6a. Vertex, HK, and I have another point, so that would be an XY. So I'm going to fill into the vertex form equation. So again, that's looking at my formula sheet. Okay, replacements. So y, I'm going to go -11. A is the thing I'm trying to figure out. X is 2. Okay, here's where maybe it'd be an easy spot to make an error. How do I write subtract h when it is a -2? Now it's going to become a +2. You do opposite, right? When you see a minus h, then you're going to have to always write the opposite. And then +5. Okay, we're going to solve this. So I'm going to subtract 5. Okay, 2 plus 2 is 4. 4 squared is 16. Therefore, if I divide, A equals -1. So I'm going to write the formula with everything except x and y open. So remember, at the point at the end, you want to make sure you're ready if you wanted to type it into your calculator. Okay, word problems. So I need my calculator. I am doing a golf ball being hit. So I'm going to graph that. Okay, I'm just going to start with a zoom 6 when you're done. So I did a 10 by 10 grid. Okay, everyone's looking like that. Okay, so when I look at the window, I don't really need all this negative x. So I think I'm going to chop it off at -5 here, and I'm going to make it higher. So window, x, -5, low, y max, I don't know. What do you want to try? 40? Don't know. We'll just guess 40 and we'll play around. Let's see. Okay, so not quite.
80 works.
So we'll go with 80. I think I'm just going to change my scale to a 10 because 80 is a pretty large amount to go up by ones. So that was an 80. Okay, question 1. What is the Y-intercept? So I'm going to trace. That gets me my mouse, and I'm going to say, hey, go to 0, enter. Go to 0, enter, and it's 11.5. So that Y-intercept is 11.5. What does it represent in this scenario? So we are a person hitting a golf ball from the top of a hill. So what does this represent? This is where they're starting from. So that's the hill. So I wrote that that's the height of the hill that they're starting from. By the way, I knew that the Y-intercept was 11.5 without graphing it. And here's the reason why. If the time was 0, that would be gone, that would be gone. So at a time of 0, I'm at 11.5. Okay, find the roots. So find the X-intercepts. Find the X-intercepts. So can you calculate? Can you calculate those two numbers? Okay, were you good with that? Left, right bound? Okay, so what do these X-intercepts represent in this scenario? Remember, we have a golf ball and we're hitting it in the air, and then, so I'm going to cross this one off. It doesn't make sense because this is saying it's the time, so that doesn't even make sense to have negative time. So this is how many seconds to hit the ground. So how many seconds it took to hit the ground? Okay, so when I look at this graph, this is the only part that makes sense. Okay, I took this off because time cannot be negative, so that didn't make sense over there. And I took this off because the ball is not under the ground. Okay, does that make sense to you visually? The ball is hit, the ball goes up, the ball hits the ground. That's the only part I care about. So what's the domain? What's the time starting at? So the domain is the time. What's the time starting? 0. When does the time end? When it hit the ground, it ends, so 5.22 seconds. Okay, what's the range? What's the lowest height? So 0, ground level. A height of 0 is the ground level. And what's the highest height? I don't think we have that number yet. So we need to get that number. What's the highest height it will go? So calculate the max. Okay, so I got my mouse to get to the max. And when I look at it, what is the highest? 71.88. That one. I don't look at the X, I look at the Y. Okay, number 8. You are selling tickets for a concert and you're going to be making revenue. So let's go revenue equals, it will be the price times the number of tickets. That's how you make money. Your ticket price times however many tickets you sell is the money you make. What is the revenue, just by the way, this isn't the part of the equation, but what's the revenue at the start right now? $10 tickets, 500 people come. What is that revenue? $10 tickets, 500 people. You're already going to make 5,000 bucks at the start. Okay, so let's make an equation here. Revenue equals a big bracket, a big bracket. So the price, we had a $10 ticket. The number of tickets, we had 500 people. Okay, if you increase the price by 50 cents, increase by 50 cents, right? I'm doing a 0.5, 50 cents is $0.5. 10 fewer people will come. Okay, I'm ready for my calculator at this point. I'm going to type it as I see it. All right, when I go to my window, I know I'm already not going to see this graph. We already had a revenue of 5,000. So let's go window Y max. Let's go 8,000. And I'm going to go up by, do you want to do by 500s? So I changed it to 8,000 Y max on a scale of 500. Okay, let's see. I have no idea, but I knew that that had to be big. Graph. Okay, I think that the height is good. So let's go wider. So window, let's go -15 to, what do you want to do, 30? I don't know how it's going to go. -15 to 30. Pretty good. We can go, instead of 30, we can go, I don't know, what do you want to do, 50 maybe? Okay, so I like that. Okay, so it's going to take some trial and error, and that's fine. Okay, let's get this coordinate, and then we'll decide what we want to do after. But let's just get that coordinate. Okay, so this is my coordinate. The x value is 15. So first question A, what is the ticket price? So here's the ticket price. So 10 plus 0.5. Now I know that I want x to be 15. So I want to make 15 50-cent increases. Okay, so you should sell tickets for $17.50. What's the largest revenue? So here it is. I already have that answer. That's the largest revenue I'm going to make. What will be the ticket price when we start to drop below the original revenue? So the original revenue was 5,000. So right there, that's 5,000. So here the revenue is above 5,000, and then at this point it's going to be below 5,000. Does that make sense? So I started at 5,000, then I started making more money, and then less money, and then I got to a point here where I'm even making less than 5,000. So what is that? I need that intersection. Okay, so go Y2, 5,000. Okay, and we want the intersection over here on the right, just that one. So I got when X was 30. Okay, so if X was 30, that's going to do that. But what ticket price? So I'm going to do 10 plus 0.5 times, and now I know X is 30 instead. Okay, so same format as the other one, but just a different X value. So when your tickets are, if you make your tickets more than $25, you're going to start to just lose money. Okay, 2 more questions. A diver is jumping off of a 4-meter platform. So your diver is here at a 4-meter platform. And then they reach a max height. So they go up. And then your diver will splash in the water. They reach a max height of 5.2 meters, 0.19 seconds later. Okay, so be careful about 5.2 is the Y, not the X, because height is the Y. X is the time. Okay, so now this is the vertex. So that will tell me an H and a K. This is a Y coordinate, a Y-intercept. So my actual point would be that if I wanted to talk about X comma Y. Now I'm going to develop an equation. So I'm going to use that. So we've already done this one today. Vertex equation. And I'm going to have to figure out A. Okay, so here's my plugins. Y is going to be a 4. The X is going to be a 0. Minus H, so minus 0.19 squared plus 5.2. Okay, so I plugged them all in. Okay, our algebra is to minus the 5.2 out off the end. So I minus 5.2. Now I'm going to do 0 minus 0.19 squared is 0.0361. Okay, so my A value, negative 1.2 divided by that, is negative 33.24. Okay, now I have to actually make an equation which I can put into my calculator. So y equals negative 33.24 x minus 0.19 squared plus 5.2. Okay, so that's what we did before. We put everything in from before except for x and y now are open. Okay, so what I'm going to do first here is I'm going to go clear, because we had a big equation in there. I'm going to clear the y, and I'm also going to zoom 6 it. Now let's just reset. Everything's 10. Okay, now I'm going to type that in. Okay, if you want, you can graph it. It's pretty narrow. So here's my question about x. Like, look at this x value. This x value is 0.19. So on my window, why don't we go from like -2 to 2? We don't need much x because that's an x value of 0.19 right there. So, okay, why don't you hit trace? Does it match our stuff? 0. Look at the height. 4. 0.19. Yep, the diver's up at the top at 5.2. When or how long does it take the diver to reach the water? Can you get me this value now? Okay, so we had to do all that work just to get this value. So calculate the 0. I got 0.59 seconds. A match? .59 seconds. Okay, we have a circular water fountain, and then we're going to put some seating area around it. The designer wants the area of the water fountain area to be the same as the seating area. So pi r squared is the area of a circle. The radius for the entire project is 14 feet. So what should be the radius of the water, just the water fountain? Okay. So the whole circle, the whole thing, would be pi times 14 squared, pi r squared. Okay, now we're going to call just that radius, we're going to call it x because we don't know it. So the water fountain is going to be pi x squared because we don't know. And the seating area, so that portion around, do you understand it's going to be the entire thing minus the middle? The whole thing minus the middle will leave me with the outside ring. So those are the things I know. Okay, so I want the water fountain area to equal the seating area. That's my goal, is to get the fountain area to equal the seating area. So the water fountain area is pi x squared. And I want it to equal the seating area, which is the whole circle minus the fountain. So the whole circle minus the fountain see where I'm getting those numbers down? This is the whole circle, subtract the inner fountain will be that outside piece. And I want that to equal that. Okay, so we're going to go into our calculator. This will be our Y1, this will be our Y2, and we're going to figure out how to make it work. So I'm going to clear and I'm going to zoom 6. So I cleared what I had and I zoomed 6 just to reset. So zoom and then hit 6. Reset it, y equals. Okay, your pi button, does everybody know you're going to have to hit yellow and then this little upper arrow button? So pi x squared and then pi times 14 squared subtract pi x squared. I'll graph it and I'll see if I can get them on there. Nope. Okay, so let's try Windows, making this 100, scale 10. I don't know. See if I can see more if I do that. Okay, so that's 1,000, 100 on the Y. That works. I think I need more X though. I want to see more X. So window -20 to 20. There we go. We got it. Okay. So I want to know this intersection point. This is what my goal is. I don't care about this intersection over here because x is negative. and negative dimensions. That doesn't make sense. So can you end up with this x value? Okay, so what does this mean for the project designer when you have an x value of 9.9? What is it even talking about? So the designer will have to make that 9.9 feet. And that would be 4.1 feet. Because we knew? Like that. Then the whole radius was 14. So that's what the whole design is going to look like. That's what this number is.